Welcome to this explainer. Okay, today we've got something really exciting lined up. We're taking a FortiGate firewall, which, let's be real, might just be a heavy piece of hardware sitting in a cardboard box on your desk right now, and we're going to completely transform it. We're turning it into a fully intelligent, multi-layered network gatekeeper. If you're looking to build a rock-solid foundation for your network security from the literal minute you power it on, well, you're exactly where you need to be. Let's get into it. Here's our game plan for this day one setup. We'll quickly hit the modern security context, move into initial access, map out our network interfaces, establish static routing, lock down administrative access, and finally, hook up that FortiGuard threat intelligence.
All right, Section 1, the modern security context. So why do we even need a modern device like a FortiGate in the first place?
You know, historically, network security was all about building this massive, strong perimeter, like a castle wall. You had your entry point firewall, and once you were inside the building, you were just inherently trusted. But today's landscape is completely chaotic. There is absolutely no identifiable perimeter anymore. Think about it. Mobile workforces, the cloud, IoT devices everywhere, bring your own device programs. Malware doesn't even have to break through a wall anymore. It literally walks right through the front door on an infected USB drive or a compromised smartphone. Zero internal trust? Yeah, that's our new baseline.
And because of this chaos, FortiGate really shines by adapting to these multifaceted threats. It actually takes on different roles depending on exactly what your network needs. For example, you might deploy it as a data center firewall so you can monitor server requests without adding a bunch of latency, or maybe as an internal segmentation firewall to contain breaches that, unfortunately, have already made it inside your network. It's just an incredibly flexible platform. Moving on to Section 2, connecting and initial access. It's time to wake up the hardware. Okay, waking up the hardware is straightforward, but it demands some strict discipline right out of the gate. First up, you'll plug your computer into port 1, or the dedicated management interface if you've got a higher-end model. Next, fire up your browser and go to the default IP, which is 192.168.1.99. You'll log in with the username admin and, here's the absolute crucial part, a completely blank password. Now, your very first action before you click around or do anything else must be changing that blank password to a complex one. Seriously, consider this your first vital security best practice, firmly locked in.
Now, out of the box, your FortiGate operates in NAT mode. There's also transparent mode where the firewall acts kind of like a layer 2 switch without IP addresses on its interfaces. But for this explainer, and really the default behavior you'll see, we're focusing on NAT mode. In this mode, the FortiGate acts as an OSI layer 3 router. Packets are routed by IP address, which simply means every single interface handling traffic absolutely requires its own IP address to function.
Which brings us to Section 3, configuring network interfaces. Basically, it's time to map out the physical doors of our corporate building.
So, a critical concept to grasp here is the difference between an interface role and an interface alias. They sound kind of similar, but they do completely different things. A role, like LAN, WAN, or DMZ, actually changes the GUI itself. It actively hides specific settings to prevent accidental misconfigurations. Like, if you set a role to WAN, it automatically hides the administrative ping option. Why? So your external interface doesn't accidentally become the victim of a denial of service attack. An alias, on the other hand, is literally just a friendly, customized name, something like marketing_subnet, which simply makes your policy lists way easier to read.
Seeing this in the interface is super straightforward. You just assign the alias at the top, and then you select the role right below it in a drop-down menu. Quick pro tip here, if you're ever looking for a setting and it's mysteriously vanished from your interface menu, check the role. We can always switch it back to undefined to unhide all the configuration options if you're ever dealing with an unusual edge case. And once you manually assign a static IP to an interface, you can flip on its internal DHCP server capabilities. And let me tell you, these are powerful. You aren't just blindly handing out IP addresses, you're automatically configuring clients with DNS and NTP servers. You can even map specific IPs to known MAC addresses for really tight control, establish precise address ranges so you don't run into network conflicts, or even use DHCP relay if you're managing addresses across multiple external subnets. The whole shebang is right there. All right, Section 4, establishing static routing. It's time to give the firewall a map of the hallways so traffic actually knows where to go. Configure default gateway first. Look, I really cannot emphasize this rule enough. Before you even think about building fancy firewall policies, your routing must be established. Without a static route, your FortiGate is effectively flying blind. It's not going to respond to outside packets, and even worse, it won't be able to connect to the internet to pull down its own crucial security updates. So, how do we fix this? We manually configure a default static route. We set the destination to 00000/0, which, as you probably know, is just networking shorthand for literally any unknown destination. Then, we tell the FortiGate to forward all of that unknown traffic out through our internet-connected interface straight to the gateway address of the next router in line. It's a simple step, but absolutely foundational to getting things running. Moving right along to Section 5, Securing Administrative Access. Time to lock down the control room.
I want you to ask yourself a question right now. Who actually holds the keys to your network, and from what physical or digital locations are they even allowed to use those keys? Answering this brings us to two huge concepts: administrator profiles and trusted hosts.
Look, relying solely on the default super admin account is incredibly dangerous. It's basically a root super user. It holds the master keys to every single door in the building. Creating custom restricted profiles based on actual job necessity is just a fundamental practice for damage control. You could create a profile that only lets a user view VPN settings, or maybe one strictly for creating firewall policies. That way, if a restricted account gets compromised, the breach to your FortiGate is contained, rather than total devastation. Next up, we want to implement an invisible shield against unauthorized logins, and we do this using trusted hosts. By default, administrator accounts allow logins from 0.0.0.0/0, meaning literally any IP address on the planet. If we change that to a specific trusted subnet, say 10.0.1.10, any login attempt from outside that specific IP gets blocked immediately. Actually, it's better than blocked. If trusted hosts are set up properly, attackers from the outside won't even see the login page. It's just a black hole. You've also got a choice to make about concurrent administrative sessions. Letting them run is highly convenient for sure. You can have multiple browser tabs and CLI windows open all at once. But disallowing concurrent sessions, that is definitely the more secure route. It prevents that nightmare scenario where multiple admins are logged in simultaneously and accidentally overwrite each other's configurations with conflicting changes. It's your classic trade-off: everyday convenience versus strict security. And finally, Section 6, FortiGuard Threat Intelligence. This is where we connect the brain. At the end of the day, a firewall is only as good as the threat intelligence it's feeding on. FortiGate constantly queries the FortiGuard distribution network, which is this massive global array of servers, to stay one step ahead of zero-day threats. It's smart too. It automatically prefers the data center nearest to your time zone, making sure you get the absolute fastest real-time intelligence to protect your network. Now, this interaction happens in two contrasting ways. First, you've got live queries for things like web filtering. These happen in real time over UDP to prioritize pure speed. Second, we have package downloads for antivirus and IPS signatures. These happen periodically over TCP to ensure reliable delivery. But here's the big takeaway, so listen up. Do not interrupt those TCP package downloads. If your firewall gets stuck retrying a download because of a dropped connection, it is operating blindly and it simply won't be able to detect the newest threats. All right, take a step back and look at what all our hard work today has actually built. From initial network access to IP checking, routing, and deep packet inspection, we've taken a standard piece of hardware and configured a highly sophisticated, multi-layered processing unit. Every single packet that even attempts to cross your network boundary now has to survive this rigorous gauntlet. You've built the foundation perfectly. Your firewall is awake, properly routed, heavily secured at the admin level, and actively pulling down the latest global threat intelligence. So I'll leave you with this thought. Now that your network gatekeeper is completely prepared for deep packet inspection, what firewall policies are you going to build first to defend your digital perimeter? Dive into your network requirements, start crafting those policies, and I'll see you in the next explainer.